Welcome to Understand the Math. In this video, we're going to learn about compound interest. Whether you're analyzing investments, building savings, or solving problems for class, understanding how compound interest works is essential. We'll begin by reviewing the key formulas, and then we'll walk through example problems, first with periodic compounding, and then with continuous compounding. Let's start with the basics. What exactly is compound interest? It's interest calculated not just on the initial principal, but also on the interest that's been added over time. In other words, your money earns interest, and then that interest earns interest too. It's a powerful concept because your money is working for you more and more over time. In this video, we're going to look at two main types of compounding: periodic compounding and then continuous compounding. Let's first look at periodic compounding. This is probably the type that you're most familiar with. This formula might look a little intimidating at first, but don't worry, we're going to break down each part. A is just the amount in the account after T years. P is called your principal, and it's the amount that you're going to be investing. R is just the annual interest rate, and it's written as a decimal. N occurs two places in the formula, and it's the number of times interest is compounded per year. For example, it might be compounded annually, quarterly, monthly, or even daily. And the last variable is T, and it's the number of years that your money is invested. Now let's look at the formula for continuous compounding. Unlike periodic compounding, continuous compounding assumes that interest is added at every instant rather than at set intervals. The formula for continuous compounding uses many of the same variables that the periodic compounding formula does. It uses A, P, R, and T. And then the formula also has the letter E in it. And E is Euler's number, and it's approximately 2.71828. Let's now see how all this works by going through some periodic compounding examples. In our first example, Noah invests $5,000 at an interest rate of 4% per year. We're asked to find the amount in the account in 3 years if interest is compounded annually, quarterly, and then monthly. Because the compounding is done annually, quarterly, and monthly, we are going to start with a formula for periodic compounding. That formula is A is equal to P times 1 plus R divided by N raised to the NT power. Let's start by highlighting in green what we want to find. We want to find the amount in the account in 3 years. So we're going to be finding A. Let's now write down what all the other variables are. Our principal P is the amount we invest, and that is $5,000. R is our annual interest rate, and we're told that that is 4%. We need to convert this to a decimal. Whenever you have a percent, that's just the number divided by 100. And then to make it a decimal, you just move the decimal point 2 places to the left. So we have 0.04. We'll hold off for a minute on writing down what N is, and then we'll go ahead and jump to T. T is the number of years, and we're told that we want to find the amount in the account after 3 years. So T is equal to 3 years. Let's start by finding the amount in the account if we compound annually. Whenever we compound annually, our N is going to be equal to 1. Plugging all these values into our formula, we get that A is equal to P, which is 5,000, times 1 plus R, which is 0.04, divided by N, which is 1, raised to the N, which is 1, times T, which is 3. Now all we have to do is plug these numbers into our calculator. This is just 5,000 times 1.04 cubed, and that gives us a value of $5,624.32. Let's go ahead and highlight that. Now let's see how much money is going to be in the account in 3 years if the compounding is done quarterly. When the compounding is quarterly, it is done 4 times a year, so N is going to be equal to 4. And then A is 5,000. 1 plus 0.04 divided by 4. And then in the exponent, we have a 4 times 3. This gives us 5,000 times 1.01 raised to the 12th. You put all that in your calculator and you get back $5,634.13. Now let's do our last one. Our last one is when we compound monthly. For monthly compounding, N is equal to 12. And then our A is 5,000. 1 plus 0.04 divided by 12. And then in the exponent, we have 12 times 3. This gives us A is equal to 5,000, 1.0033, and I'm going to put a bar up there because that's repeated. And then 12 times 3 is 36. And I see we're running out of room here. Let's see if we can squish it in. When you put these numbers in a calculator, you end up with $5,636.29. Let's go ahead and let's highlight these answers. And you can see that the more frequently you compound, the more money you get. And that's because your interest is earning interest at a quicker rate. Let's now look at our second example. In this example, we're told that Maya needs $10,000 in 5 years. We're asked to find how much she will need to invest now at an annual interest rate of 3%, compounded semi-annually. Semi-annually compounding is considered periodic compounding, so let's start with our formula. A is equal to P times 1 plus R divided by N raised to the NT. Let's highlight what we want to find. We want to find how much she needs to invest now. So that is the principal P. Let's now write down what all the other variables are. The amount A is what she wants to get in 5 years, and that is $10,000. Our interest rate R is 3%. So this is just 3 divided by 100, which is 0.03. Again, just moving the decimal point 2 spaces to the left. Now we have N. N is the amount of times the interest is compounded per year. Semi-annually means 2 times per year, so N is going to be equal to 2. And then our T is the number of years the money is invested, and that is going to be 5 years. Let's go ahead and let's put all of this into our formula. Our A goes on the left, and it's 10,000. And then we have P, which is our unknown. And then we have 1 plus R, which is 0.03. We're going to divide that by N, which is 2. And then we have in the exponent N, which is 2, and then T, which is 5. Let's go ahead and simplify this. We have 10,000 is equal to P times 1 plus 0.015 raised to the 10th. We want to solve for P, so let's get that all by itself. So P is equal to 10,000 all divided by 1.015 raised to the 10th. Now you can put that in your calculator, and what you end up with for an answer is $8,616.67. And that's the amount that Maya needs to invest now to get $10,000 in 5 years. Let's look at one more example. This one is definitely the hardest one because we're going to have to use logs and solve for t. We're told that Omar invests $20,000 at an annual interest rate of 6% compounded annually. We're asked to find how long, that always means that you're going to solve for t, will it take his investment to grow to $80,000. The interest is being compounded annually, so that's periodic compounding. So let's write down our formula. A is equal to P times 1 plus R divided by N raised to the N times T. Now let's go ahead and highlight in green what we need to find. We need to find how long it's going to take his investment to grow, so we're going to be solving for T. Notice that it's up in the exponent, and that's why we're going to have to use logs. Let's start by writing down what all the other variables are. A is the amount that will eventually be in the account, and that is going to be $80,000. P is the principal, and that is the amount that is invested initially, and that is $20,000. R is the annual interest rate, and that is 6%, which is just 6 divided by 100, which is 0.06. N is the number of times the interest is compounded per year, and it's compounded annually, so it's only going to be compounded once per year, so N is just equal to 1. And that's it. We have everything written down. Now let's go ahead and let's plug all these numbers into our formula. Our A is 80,000. Our P is 20,000. And then we have 1 plus 0.06 divided by N, which is 1. And then we have N is 1, and then T, I'll highlight that so we know that that's what we're going to be solving for. Now let's go ahead and simplify. I think the best thing to do is to go ahead and divide each side by 20,000. $80,000 divided by 20,000 is just 4. And then we have 1.06 raised to the t. To solve for t, we are going to have to use logarithms. I have a video on this if you need to review that concept. We can use the common log or we can use the natural log. I'm just going to use the common log, and I'm going to take the common log of both sides. The common log is just the log of base 10, and we just write it as log. So we're going to take the log of 4, and then we're going to take the log of 1.06 to the t. A property logs is that if you have a variable such as t up in the exponent, you can pull that exponent in front of the log. So we're going to write this as log of 4 is equal to t times log of 1.06. Now we can divide both sides of the equation by log 1.06 and just solve for t. T is then log of 4 all divided by log of 1.06. You can put that in your calculator, and when you do, you end up with 23.8, and t is in years, so this is 23.8 years. So Omar starts with $20,000. He invests it for 23.8 years at 6% compounded annually, and he ends up with $80,000. Let's now look at some examples when the compounding is done continuously. In our first example, we are told that Sylvia invests $10,000 at an annual interest rate of 5% compounded continuously. We want to find the amount in the account in 30 years. Because we're told that the compounding is done continuously, we are going to use the formula A is equal to P times E raised to the RT. We want to find how much is in the account in 30 years, so we're going to be finding A. Let's start by writing down all the other variables. Our P is the amount that's going to be invested, that's called the principal, and that is $10,000. R is the annual interest rate, and that is 5%. So this is just 5 divided by 100, which is 0.05. R always has to be written as a decimal. And then T is the number of years that the money is invested, and that, in this case, is 30 years. Now let's go ahead and let's put all these values into our formula. This gives us A is equal to 10,000, E to the 0.05 times 30. When you do a lot of these problems, you can probably not write down all the variables first and just go ahead and plug them into the formula. This is equal to 10,000 E to the 0.05 times 30, which is just 1.5. Now you can go ahead, put that into your calculator. If you don't have an E, just remember that E is approximately 2.71828. And you get back a value of $44,816.89. And that's how much the account is going to be worth in 30 years. Let's now look at our second and our last example. Liam invests $7,500 at an annual interest rate of 8%, compounded continuously. We're asked to find how long, that means we're going to be solving for T, will it take for the investment to be worth $45,000. We're working with continuous compounding, so we're going to start with the formula A is equal to P times E to the RT. We want to find how long it's going to take for the investment to be worth $45,000, so we're going to be solving for T. Let's write down what all the other values are. A is the amount the account's going to be worth, and that is $45,000. P is the principal, that's the amount invested, and that is going to be $7,500. R is the annual interest rate, and that is 8%, which is just 8 divided by 100, which is 0.08. Now we can go ahead and plug these values into our formula. On the left, we have 45,000. And then on the right, we have 7,500 E to the 0.08 times T. Let's go ahead and simplify this by dividing each side of the equation by 7,500. That will isolate our exponential. $45,000 divided by 7,500 is equal to 6. And then on the right, we have E to the 0.08 times T. Notice that T is up in the exponent, so we're going to use logs to get that T out of the exponent. Because we have an E, the best log to use is the natural log. So I'm going to take the natural log of both sides. So we have ln 6 on the left, and then on the right, we have ln of E to the 0.08 T. When we have an exponent in a logarithm, here's the exponent right here, we can pull that whole exponent out in front. And that's exactly why we use logarithms to solve this type of problem. So we have 0.08t out in front, and then we have natural log of e. Natural log of e, by definition, is equal to 1. And now we can easily solve for t by dividing both sides of the equation by 0.08. Let me just write this clearly. Our t then is ln of 6 divided by 0.08 because that's what you're going to have to put in your calculator. When you put that in your calculator, you get a value of 22.4, and it is in terms of years. It is going to take 22.4 years for the amount invested, which was $7,500, to grow to $45,000. And that's it. Now that you've seen how the formulas work and how to apply them, you've built a solid understanding of compound interest. Keep going by working through more problems. That's how understanding turns into confidence.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.